Having recently talked about the periodic table and studying ionic bonding at the moment, I think it's important that we talk about periodic table and valency. What is valency? Valency is the combining power of an element. So how many electrons are involved in bonding for that element? It's related to how many electrons there are in the outer shell of the atom. It is not the same as, but it is related to how many electrons in the outer shell. The valence electrons are the ones that are involved in forming a chemical bond. So for metals, it is the number of electrons in the outer shell. For non-metals, it's how many electrons it will gain to have a full outer shell. So if we look at this table, initially it looks quite complicated. It shows us the groups at the top here, and it shows us that group number is the same as the number of outer shell electrons. So those elements in group 1 will have 1 outer shell electron, group 2, 2 outer shell electrons, and so on all the way through. If an element has 1 outer shell electron, its valency will be 1. Its bonding power, its combining power will be 1. And the typical charge will be +1 because it will lose that 1 outer shell electron. In group 2, with 2 outer shell electrons, it is easier for it to lose those 2 electrons to gain a full outer shell. And when it loses 2 electrons, it becomes positive by 2. And so on through here. If we go to group 7, it's important to understand group 7. Group 7 has 7 outer shell electrons, just 1 short of the 8 that make a full outer shell. So its valence is 1 because it is short of 1 electron to make a full outer shell. If it does gain that 1 electron, it gains a negative charge, a single negative charge. So its typical charge is -1. So using that, it's important to notice that group number is always the same as the number of outer shell electrons. If you know the outer shell electrons, then it's easy to predict how many electrons the atom will need to lose or gain to attain full outer shells of electrons. Electrons that are lost by metals must be transferred to non-metals. This transfer of electrons is called ionic bonding. Ionic bonding. We've studied ionic bonding, and we've said that ionic bonding occurs when a metal atom transfers an electron or electrons to a non-metal atom, so that both atoms attain a full outer shell. The significance, the importance of this is that they attain a noble gas electron arrangement, so full outer shells. We've looked at sodium chloride, and we see the sodium atom with its 1 electron in the outer shell, losing that electron or donating that electron to the chlorine atom. That chlorine is short of 1 electron, and so when it gains that single electron, it becomes chloride, and the sodium gains a positive charge. It's lost 1 negative charge, so it becomes positively charged, and the chloride gains that electron and becomes negatively charged. When ionic bonds form between group 1 atoms and group 7 atoms, the sodium group 1 element has 1 outer shell and a valency of 1, so in order to attain a full outer shell, it loses an electron. The chlorine atom, group 7, has 7 outer shell electrons and a valency of 1, so in order to attain a full outer shell, it gains 1 electron. So that electron is transferred. The compound formed has the formula NaCl, sodium chloride. Notice that when we write the formula, we don't have to write in these superscript charges that you see on the sodium here and the chloride there, because these charges balance each other out. That's the important thing. If we get on with some ionic bonding practice, when an ionic bond forms between magnesium and oxygen, the following happens. Magnesium's in group 2, so it has 2 outer shell electrons and a valency of 2. Therefore, it forms ions with a double positive charge, a 2+ charge. Oxygen's in group 6, so it has 6 outer shell electrons and a valency of 2. Therefore, it forms ions with a 2- charge, double negative charge. Okay, there you can see the 2 electrons from magnesium in magnesium's outer shell being transferred to oxygen's outer shell. Magnesium needs to lose those 2 electrons to gain a stable noble gas structure, and oxygen needs to gain 2 electrons. So it suits both of them. Magnesium transfers electrons to oxygen. Magnesium becomes positively charged. Oxygen becomes oxide, which is negatively charged. And so we have a compound called magnesium oxide. And the formula is MgO, 1 magnesium, 1 oxide ion. Let's try between magnesium in group 2 and fluorine. Magnesium is in group 2, so it has 2 outer shell electrons and a valency of 2. Therefore, it forms ions with a double positive charge. Fluorine is in group 7, so it has 7 outer shell electrons and a valency of 1. So it forms ions with a single negative charge, F-. And if we look at the electron transfer there, you can see magnesium's got 2 electrons to give away, but each fluorine only needs 1 electron. So the magnesium donates one of its electrons to one fluorine atom and the other electron to the other fluorine atom, forming magnesium fluoride. This time the formula is slightly different because each magnesium needs to transfer electrons to 2 fluorine atoms, and so we form MgF2. Here you go. Here is some bonding practice to do on your own. Following what I've just shown you, you're going to fill in the electronic structures of the atoms first, magnesium oxide, and then the ions, not forgetting to put the charges just on the top right outside the square brackets. Okay, so you've got 4 to do: magnesium oxide, lithium chloride, sodium oxide, magnesium fluoride, and then the last one you're going to try, which is a little bit more complicated, is aluminium and chlorine. So aluminium chloride.